Alright, time to learn another derivative and integral. When we've been doing these power rules for integrals, we would always add 1 to our exponent and then divide by our new exponent. Well, if we try doing that when we have x to the negative first power, so that's to the first power, x to the negative first, you would have x to the 0 when you add 1, but you can't divide by 0. That means that this really can never happen. So that means, well, does that mean we can never take the integral of this? No, absolutely not. We just need another rule for it. And the rule ends up being that that integral is the natural log of the absolute value of x. And same thing if we went the other way, that means the derivative of the natural log is 1 over x. So, let's start with derivatives and start going that way. If I want to find the derivative of the natural log of something, well, it's just going to be kind of like we've done before. Whatever's on the inside is now going in a denominator, and then we always need to multiply by derivative of the inside, so times 2x. I could simplify and put that 2x up top if I wanted to. Alright, same thing here. I would have 1 over x plus 4, derivative of the inside is just 1, so I'm done. Now these ones here are going to be a little more tricky because, well, look what happens. We got like product rule and stuff. So this one, x times ln of x. First times derivative of the second, derivative of this is 1 over x, plus the second times the derivative of the first. Can I simplify it? Well, yeah, x times 1 over x will just cancel out for 1. ln of x times 1 is just ln of x. For product rule again. So first times derivative of the second plus the second times the derivative of the first. And then can I simplify it? Yes, I would make it x squared over x minus 3. And then I would make this just to be in standard form, 2x times the ln of x minus 3. Just to try to simplify it. And then this one right here, you can do with either product or quotient rule. I'll let you try to go through on that. And actually, here's what you would do if you get the quotient rule. 1 minus ln of x all over x squared. A couple different ways to do it, but that's quotient rule is the way I would. Now, looking at integrals now. So now we're going backwards. The integral of 1 over x is just immediately the natural log absolute value of x plus c. This absolute value is important because I can't have natural log of a negative number. So this must always be in absolute value. This one right here, also very simple. This is going to be the natural log of x minus 3, also plus c. But now, what happens if what's under here does not have a derivative of 1? Well, this is where we're going to have to start doing these u and du's again. U is just going to be that bottom, 2x minus 3, means du is 2dx. So I would rewrite it as the integral of 1 over u, and dx is now would be du over 2. So that's 1/2 times the integral of 1 over u du. Now I can do my integral. It's 1/2 of the integral of 1 over u would be the ln of absolute value of u plus c. And now just plug back in. 1/2 ln of 2x minus 3 plus c. Let's try a couple more examples. Actually, no, we'll save the examples for another time. What I first want to point out is that when you had any power up here, any power except for 1, we can use our normal power rule. The only time that we have issues is when we have a power of 1. That's when we have to use ln of x. Normally we will use normal, but when you do a u substitution, or if you just notice it immediately as being to the first power, that's when you do ln of x. Here's a couple more examples. The first one is worked out for you. I would suggest trying these and seeing how you can do. And you will use u and du for a lot of them. Best of luck. We'll continue with this on A Future Date.